So any finalists online? Yeah. So can you please inform your fellow mates to join immediately?
Can it, sir? We'll wait for 2 more minutes and then start, sir, because the participants are still joining. That's all.
Sir, good morning, sir. Shall we start, sir?
Yes, madam.
Okay.
Ma'am, shall we start?
Yeah. I think you can.
One second. ಒಳ್ಳೆಯದು. Thank you. Yes, we can start, madam.
Okay, sir. Good afternoon, one and all. I welcome you all to the webinar on Essence of Artificial Intelligence, organized by the Department of Computer Science and Engineering. The Department of Computer Science and Engineering has come forward with this initiative to educate the students about the emerging technologies. We have with us Mr. Kenneth Ayyappa as a resource person who is an authority on Essence of Artificial Intelligence, and he has willingly agreed to share with us his rich expertise on today's topic. May I call upon Mrs. Aishwarya Rajiv, Assistant Professor, Department of Computer Science and Engineering, to deliver the welcome address.
Only 10 minutes.
Good afternoon, one and all. It's a glad welcome we bring to you this morning, filled with desires, hopes, and dreams we all share. Foremost, I would like to welcome the resource person, Mr. Kenneth Ayyappa, CIT alumnus, data scientist, Cyber Bangalore, for taking time from his busy schedule to enhance our knowledge. A warm welcome to you, sir. We look forward to have a great session with you. It's my pleasure to welcome Dr. M. Basavaraj, Principal, Coog Institute of Technology, who has motivated us to conduct this event. A warm welcome to you, sir.
Thank you.
I'm honored to welcome Dr. Kavita PC, HOD, Department of Computer Science and Engineering, for encouraging us to organize this webinar. A warm welcome to you, ma'am.
Thank you.
It's a true pleasure to welcome all the staff and students of the department to this program. A warm welcome to each one of you. Thank you.
Thank you, ma'am. I request Mrs. Soumya Siti, Assistant Professor, Department of Computer Science and Engineering, to introduce the resource person, Mr. Kenneth Ayyappa.
Good afternoon, everyone. It's my tremendous honor to introduce our resource person of today's webinar, Mr. Kenneth Ayyappa, a software enthusiast who is working as a senior data and ML engineer at Saiva. Born in Kodagu district, Mr. Kenneth Ayyappa completed his schooling from Lions School, Gonikappa, and his pre-university education from Virajpet. He pursued his bachelor's degree in Coorg Institute of Technology, Ponampet, in the year 2012. He started his career with the Sustain Communication Technologies, for which he got placed during his graduation, but later joined Infini Technology as a full-stack developer. He gradually started his own freelance team, and he codes in 8 to 9 technologies. He's expert in technical management, agile software development, native and hybrid mobile applications like iOS and Android, server development, Python, Django, MySQL, and many more. Presently, he works as a consultant for 3 companies, which are Node Technology as an advisor, IIT Madras Healthcare Innovation Center as an engineering manager, and Saiva as data and ML engineer. It's a proud privilege to have you with us today. Thank you.
Thank you. Thank you for that.
Thank you, ma'am. I request Dr. Kavita PC, HOD, Department of Computer Science and Engineering, to address the participants.
Good afternoon, everyone. Respected Principal, Mr. Kenneth Ayyappa, colleagues, and my dear students. At the outset, I express my cordial gratitude to our alumnus, Mr. Kenneth Ayyappa, for accepting our invitation wholeheartedly to share his knowledge in spite of his busy schedule. Ayyappa, we are very proud of your achievements and very glad to have you as a resource person to this webinar. Dear students, you are very fortunate and it is quite inspiring to follow your seniors' guidance. Hope you are aware of significance of artificial intelligence and its wide scope. So you have to upskill yourself to face the global challenges. I advise dear students, please make best use of this opportunity and make it an interactive session. So based on your response, Mr. Ayyappa has expressed his interest to conduct many more sessions for you in future. So with this, I thank the principal for the support, Professor Kirtana and my colleagues for their effort in organizing this webinar. Thank you one and all.
Thank you, ma'am. I now request Dr. Basavaraj M., Principal, Coorg Institute of Technology, to speak a few words.
So very good morning to all. First and foremost, I'm extremely indeed happy that Department of Computer Science is conducting a webinar on essence of an artificial intelligence. At the outset, honorable members of our Board of Education Society, the resource persons of today's webinar, Mr. K. Ayyappa, the alumni of a CIT, Dr. Kavita Madam, the HOD of a Computer Science Department, my dear colleagues of a CIT, and my dear young student friends. First and foremost, I'm very thankful to a great alumni and the great technocrat of the field of innovation, Mr. K. Ayyappa, the alumni of a CIT. I'm extremely happy and thankful for accepting our invitation as a resource person for on the webinar, the essence of artificial intelligence. Just when I was going in the morning, the use of an artificial intelligence technique in a computer, it is assisted instruction. So in the short, we call it as artificial intelligence, we call it AI. It is an assisted instruction to tell about an overview. One of the major goals of a research in artificial intelligence is the representation of a knowledge so that a computer can solve problems or communicate in a manner which exhibits by using the common sense. I want to share the word the common sense. A few years back, I invited one of the greatest scientists from ISRO, Mr. Swaminathan, and he worked along with the president of India, Dr. APJ Abdul Kalam, and when they visited USA, the NASA, and regarding there was a presentation in the NASA regarding one of the satellite, and the rover, that's a rover, and it was not moving, it was been stuck. It was stuck in the planet. After seeing the video presentation, so there was a logbook outside, and Mr. Swaminathan wrote the comments while coming back after seeing the presentation. And the Americans, they saw the comment after 3 months. They invited again Mr. Swaminathan from India, who is working as an ISRO scientist, as a mechanical engineer, back to America, and he gave the basic explanation why the rover is not moving forward. So that is he played very common sense. The common sense plays very, very important role sometimes. So with his common sense, he's resolved the issue which was not able to solve by the NASA, were the greatest scientist. So to add a little bit more regarding the artificial intelligence, so makes it possible for machines to learn more experience, just the new inputs, and perform human-like tasks. That is example you hear about today, that the chess playing, the cards playing with the computers, and self-driving cars, which is being done by means of the artificial intelligence. So at the end, I appeal all the students of CIT, the third and final students, to make a best use of this webinar and expertise yourself in the AI and become a great scientist or innovator to solve the result, like our alumni, Mr. K. Ayappa. Thank you for giving me opportunity to speak, to share my few words. Thank you.
Thank you, sir. We look forward to have a highly educative session with you, Kenneth, sir. I hand over the session to you.
Good afternoon, guys. First of all, I would like to thank the CS department and the entire CIT college for inviting me, giving me this opportunity. And I'm definitely sure students would be like, okay, this guy is going to come talk something and go, let's just be online. Let's try to see. Okay, but guys, I'll tell you something. When I was in your place, in your position, final year or pre-final years, so one thing that comes to mind is like, after engineering, what next? So that's something always comes to your head. So if you are curious by nature, always it's good that you will try to see that how is this mobile applications working? How are these WhatsApp working? Someone has built this WhatsApp and it's quite famous, or Snapchat or Facebook or any sort of huge applications. So why not we try to move towards that direction wherein we can build this? That curious nature is something that will definitely help you in scaling your careers. That's what I would say, like, because from my experience, I would say like, you study any place, anywhere, doesn't matter. It's your personal interest. That's what matter, which will scale you up in your careers. Okay, today, and guys, any questions or anything that in this session, you can just interrupt me in between, or else we'll have a QA session at the end. Either should be fine with me. Okay, let me share my screen. Okay, so this today I'm not going to do a typical PPT presentation kind of a thing. Definitely, I'm not going to do all those things, but I will help you guys to understand what is the reality in the IT field. It's not like what you study in your engineering. That's not the reality. These things, what you study, algorithms or stuff that are add-ons to your career, where you learn stuff, where you can crack an interview, where you can understand the fundamentals. But when it comes to reality, wherein you join a software company, what you will be exactly doing, that's quite different from what you study in your engineering. So first thing is, like, since since the session is meant for pre-final years and final years, so both of the folks in pre-final year and final year, it's a right time for you guys to start with small mini projects or internships which will help you in your career. So first thing, let me start off with Git. I'm not sure whether you guys are aware of what a GitHub is. So if anyone is aware, you can just let me know you're familiar with GitHubs, GitHub or Bitbucket. Guys, you can talk. It's okay, fine. So GitHub is like it's a version control. One second. Am I audible, Madam Kavita, Madam? Am I audible to everyone?
Yes, Ayappa, you
Yeah.
can proceed. Yeah.
Yeah. So GitHub is a version control, or maybe you can call it like a Facebook for developers. So you spend a lot of time in Facebook or Instagram, where you put your photos, where you exhibit your things wherever you visit, all those stuffs. Similarly, GitHub is a platform where you put your codes, put your projects. So you can put it public, which is called as open source projects, or you can keep it as private, that is meant for our own companies or our own self. So generally, most of the developers, we use GitHub for all sort of projects, or maybe in terms of like having a small write-up or a presentation or something, we use these kind of things. So typically in a software, there's tech guy and a talk guy. Talk guys are like mostly presentation guys with all proper fancy PPTs. Tech guys, mostly hands-on coding. They prefer these kind of stuff. Okay, so guys, just let me know whether you guys are really familiar with what ML is, what is ML, what is machine learning, or what is AI. Since final years have an elective subject, I guess you must be familiar with what exactly is machine learning. Correct me if I'm wrong. Anyone? Guys, you're familiar with ML and AI?
Students, please respond now. Please make it an interactive session so that it will be comfortable for Ayappa to take it forward.
Yeah, otherwise I'll be just talking and you guys will be sitting somewhere. Anyway, I'll just proceed. Let's see.
So they have the subject as a core, wherein they study what the basics initially in the first module about what is machine learning, and they actually proceed with designing of maybe the hypothesis, how the hypothesis construction is done based on different algorithms.
Okay.
Nothing more in general about machine learning from the syllabus they know.
Okay. So students, I would definitely say that, see, in the current time, that's 2020, or maybe since 2012 onwards, ML and blockchain is something trending in the market. You might have heard these fancy buzzwords, ML or blockchain. So these have a wide range of applications. Both of these have been like occupying the market. Going next 10 years down the line, ML will be the market, and regular software engineer to get a job, it would be, I would say it would be difficult, because this is going to take over the entire market. ML is definitely going to take over the entire market. So let me take you through the entire stuff, like what I have for you guys. I'll not go in depth, but I'll help you guys understand what is ML, why do we need it, how is it going to be different from traditional software programming, and how will it occupy the entire market going forward. Okay. So as a definition says, let's see what machine learning is. Provide a systems the ability to automatically learn, improve, from the experience without being explicitly programmed. So typically these are the definitions that you find in internet or any place you see. So let's put it in a layman's word, what a machine learning means. Now let's assume a human being goes to a bowling centers. You are familiar with bowling centers, right? So you go to a bowling center. The first day you throw a ball, it might go to the gut, or it might go somewhere else. It's not guaranteed that you'll knock off all the pins on the first day. But gradually, maybe after like a year, you play maybe once in a month or something, you become much more better. How is that happening? Obviously, it's through your experience, or every time you play again and again, you understand what are the flaws, what are the things that you have to correct. That's like over a period of time, you gain the experience and you correct yourself. The same thing applies to machine. So that's what machine learning is like. A typical definition also says that a computer program is said to learn from experience E, wherein experience E is like you throw a ball on a bowling center with experience set. The task is here in taking our example of bowling. The task is bowling here, and the performance measure is like the first day it's like you might throw it to the gut, and the nth day you might knock all the pins in the bowling. That's the performance measure. So this standard formula applies to all the places of application. It might be anything. The standard formula is the same stuff. Experience E, task T, measure with performance measure T, and performance measure improves with the experience. As experience increases, you keep measuring the performance. Performance also improves. So suppose if performance is not improving, it means there's something wrong. Right? Okay. So people also say, what is AI? What is AI and what is ML? There's a lot of confusion between AI and ML. Most of the people don't understand what AI is and what ML is. AI is a broader concept of machine learning. It's a generic term which says that any sort of machines which are smarter, that is artificial. It's not necessary that only one segment of it. And machine learning, ML, comes under AI. So currently, under AI, there are a lot of machine learning algorithms or maybe techniques like NLP. NLP is a natural language processing, deep learning, artificial neural networks, ML. These are the different applications of the different segments that come under AI. But whereas AI is a broader perspective, it's a general term. So generally, when you talk to people, just you should be specific on like what it is, whether it's AI or whether it's ML. And AI is a generic term, so always prefer to be very specific on this part. So let's see, why do we need ML? In fact, like now, typically the question might be like, how is this ML going to take over the world, or going forward, how is it going to occupy the entire market space, or programming? So by now, sixth sem or seventh semesters, you might have done a lot of programming by now. At least C programming. In terms of C programming, I'm sure that you guys would have done C programming, where you're familiar with all these if conditions, while conditions, loops, all these things you might have come across. But how is ML different from these traditional programming? So let's go through the definition first, then I'll help you guys understand this stuff. So applications learn from experience like humans without direct programming. So what does it mean? So in our traditional programming, we suppose if we have to, let's assume we have to get the aggregate the entire scores of final years in the entire college. So what do? We put a condition or a clause saying that if final year, if the semester is so and so, then for all the students, aggregate the sum. So there is typically a if condition or a loop condition, or maybe any sort of conditions or any sort of other programming human written codes that you have to write. That's how any sort of software application works. You take up a mobile application or a web application. when a typical programmer codes, he has to handle all conditions, scenarios, wherein he has to hard code or he has to code all these cases. But whereas in ML, it's slightly different. We don't have to do much. So when exposed, so what do we do in ML? Let's see. So ML is exactly the replica or a model of a human brain. So as a child grows, initially when a baby is born, it knows nothing. It neither knows to talk, neither knows anything. There are few basic reflexes, like when it's hungry, it knows it needs to cry. It'll get milk. So that's a basic reflexes it comes up with. So apart from that, it is clueless about anything. Same thing happens in machine learning. So when we start off, we don't give any sort of data, so it's empty. It's like an empty child. It's a baby. Then gradually, for a baby, how does a mother or father take care of it? Like you give information to it. You feed information. You say, okay, do this. This is the right thing. Don't do that. You teach them the ethics. You teach them the right things. Uh, Maybe you send them to school, help them understand basic stuffs and stuff like that. Similarly, in terms of machine learning, what do? We typically give data. So when we give data, we try to solve the problem of healthcare. Like to put it short, like my expertise is on healthcare. That's the reason I'm giving examples of healthcare. Maybe like we need to replace a doctor. Like this is a very long-term goal, but definitely that's something going to happen wherein machines will replace the doctor at some day. So typically, let's assume a machine. Let's take an example of this, where a machine has to replace a doctor. What will happen? So we'll have to feed all sort of data that a typical doctor has. So, for example, MBBS graduate has 5 years experience, 5 years of study. He would have learned the entire human anatomy, and also on top of it, the masters of he'll do a masters on maybe diabetes or any sort of masters that he'll do, which is again 3 years, where he'll do a specialization. So all these data, what a human being studies, all this data has to be fed to the machine, and the machine observes the patterns. It learns the stuff. It knows this is the input and this is the output. It observes the patterns. It develops the patterns by itself, and it is going to help us in predicting. We call it like typical predictions. Maybe like example that I can give you here is like you go to a dietitian. You say that first of all, he has to examine whether you have diabetes. Once he identifies the diabetes, he gives you sufficient medication. Let's assume going forward, like maybe in next 5 years, the same thing is done by machine. So you typically walk into a clinic, a machine asks you certain set of questions, like what are the symptoms, signs and symptoms. Maybe you say, I have fever, I have leaking nose, or certain things. I have a pain in the body. These are few certain set of questions that you typically a doctor also asks. The same thing a machine would ask. Then you input these questions. Then the machine says, okay, go get these labs done. You typically go to the lab, get these labs done, give the result back to the machine. The machine will say, okay, you have this diagnosis. I have diagnosed that you have this problem, so and so problem. And this is a medication, typical medication that you have to take. So all these things, when it has to happen, underlying what is the logic that's being done. It's like typically we feed a lot of data, entire healthcare data to these machines, wherein they understand, okay, these conditions or these scenarios, these are the diagnoses that can happen. Or maybe if there is a condition, like if there is a fever, let's take a simple scenario wherein if a person has a fever, what's a typical tablets it's given? It's normally a paracetamol. The machine knows that, okay, if the body temperature is above 100, give him a paracetamol of a certain brand. This is a typical representation that happens inside a machine. But whereas to do that, typically, let's assume if machine learning was not there, how would we programmers do? We would typically write a if condition. If body temperature equals 100, above greater than 100, give him so and so a paracetamol. It's like typically a rules or a condition hard coded written. But whereas machines, they don't, in terms of machine learning, we don't do that. we will typically give the entire data set. Like I'll come to that in detail, like how do we give the data set, what happens. I'll come to that later. But I hope you're getting the essence of like how is it different from traditional programming. Okay, so when exposed to new data, these applications learn, grow, change, develop themselves. That's what it means. We don't have to code the logic for our program. Instead, we want a machine to figure out the logic from the data that we own. So typically, machine learning was in existence before 1980 or 1970 itself. There were a lot of papers written on ML. There were not a lot of papers written on AI. But why was it not in existence? Why was that not a main thing? It's only after 2010 or 2011 the entire buzz of machine learning started. Anyone curious, like why was this not happening earlier, and why it got triggered only after 2012?
Lack
Or
of
anyone?
computational power.
Exactly. So one is lack of computational power, and one more is data. For the any sort of machine learning, we need huge amount of data to be collected. So that's what all these tech giants, Google, Facebook, all these people do. Now they say that data is more valuable than gold, because and next in the next certain years, it's all everything will be driven by human data. So typically when you browse in Google, or maybe you go to the Facebook, you click on certain ads, everything is monitored and everything is captured. So they exactly know your behaviors. They exactly know your patterns. So based on that only, maybe you might have noticed that when you go to Google or any sort of websites, they give you advertisements based on your choice itself. Maybe if you have browsed Myntra and selected a particular maybe a garment or a shoes or something, you typically will start seeing advertisements of these brands or these particular things itself. How does it happen? That's because these guys have data. All these people steal our data, keep it, and then give it back to us in the form of advertisements. So yeah, that's the reason, like till 2012 or early 2010, machine learning was not a huge thing. After 2010, the computation power got increased, wherein tech giants like AWS, Google, these guys came up with a lot of big processors and machines which can run, which can process a lot of data. There are like GPUs, TPUs. Typically, in your laptop or a system, you have CPU, but on top of it, like now for the machine learning algorithm, we need GPUs, graphical processing units. And on top of it, we have TPUs also. So these are typical enhancements that were done in the period of 2010, 2012. Yeah, in that range. That's where machine learning also started buzzing up. So before that, it was like typically all on papers. Nothing was on reality. Yeah. So let's see how can we what are the different types of ML, like what is a wide use case of ML, like currently in the market you might have heard like everyone say talk about ML, or maybe even I few minutes back even I told like ML is the next big thing, or maybe next few years it's going to replace the entire stuff, it's going to cut a lot of jobs, a lot of things will happen. But what are the types of ML, how is it going to happen? Let's see that part. So typically ML, we have different types in it, that is like unsupervised learning, reinforcement, supervised learning. Yeah, typically in seven semesters, final years might have seen these kind of things in their textbooks. But like, let's see, how is it like, what is the main difference, and what do normally what is a wide use case of which type of machine learning do we normally use? Let's see that part. So supervised ML. Supervised ML, what is supervised ML? So we typically have a data, like maybe let's take an example. So if we give example, it's much better to understand stuff. Let's see, what shall we take? Okay, typically training text documents. No, let's take a simple example. Let's think of healthcare again. Yeah, since I work in healthcare, I get only healthcare examples. Sorry. So let's see in terms of diabetes predictions itself. Let's see typically for a diabetes prediction. So what do doctors need? The first, as part of first, when you go to a dietitian, what does it say? He'll ask you certain questions like maybe do you eat a lot of sugar? How often do you have hypo events or a hyper event? Or he might ask you to do a lab test on finding your blood sugar level. So these are the few basic things that your doctor says before he concludes you have diabetes. And once he concludes you have diabetes, he would say like, okay, uh, since you have diabetes, you have to take up these medications and you have to do a regular checkup and change your diet. These are few things he would suggest. So typically, how does it happen in supervised ML? In supervised, what is supervised ML first of all? So supervised ML is something wherein you know what is the output, you know what is the input. You have both the things. As part of training a data, you might have a lot of data wherein it says that certain patients who have these diabetes, they had so and so condition and they had so and so events or happenings in certain time period in their age. So these sort of data are pre-recorded, and since we know that this is the expected output and this is an this is an input, guys, stop me anywhere if you have confusion or if you want more clarity on stuff. Okay, so typically, I was saying, yep. Yeah, we know what the input is, input variable X, and the output variable Y. So typically we know what is the output and what is the input. So when we know these things and when we have data for these, the same set of things, when we have data, like maybe we have 3 years of data for the same stuff, like a typical, maybe a hospital in Narayan Nethralaya or some sort of hospital wherein all the patients go and all the data is recorded, wherein we know that these are non-diabetic patients, these are diabetic patients, and diabetic patients have so and so patterns. We have these data, we feed this data to the machine, and once we feed this data to the machine observes the patterns, it establishes pathways, it establishes patterns, and it builds a model. So this is a supervised machine learning, wherein once it builds a model, further next time a patient comes, you typically have to give these input variables. Maybe the input variables might be age, might be his diet type, maybe his blood sugar level on a range of maybe 1 month. So typically, if we give this, the machine will be able to say that, okay, in next certain days, he might have a hypo event or he might have a hyper event, something like that. So typically, supervised machine learning is a wide use case that people are using currently. A lot of places, this is the one that people use because this plays with the existing data. So once we have the data for a particular problem, people blindly go and apply supervised machine learning. So you see an example even here, supervised machine learning, wherein training of text, documents, and images. So what does it happen here? This training of text, documents, and images, this particular part, this is the actual data, and we convert it into some vectors. Let's not go into this segment. And we have the labels here. So what does this mean? Let's assume in Google Lens, people might be familiar with Google Lens, wherein you click a photo and the Google Lens identifies what is this image. So how does it happen? Same process, what I've highlighted here. You give all the images to a particular model and you label it. You say that this is a cat, this is a dog. You label the entire stuff, and the model will build a pathway, or it will channelize and it will build a pathway wherein it knows that, okay, next time I identify this kind of image, this is a cat, this is a dog. So when we have a lot of data, too much of data, we know that even if the cat is standing from behind, we know that it's a cat. If we don't have so much of data and it's very minimal, the model will not be able to find the entire, maybe a side image of a cat or a back image of a cat. So that's how supervised ML works. So what is a reinforcement learning? So reinforcement learning, especially in Indian market, not many companies or people use this. This a computer program which interacts with a dynamic environment in which it must perform certain goal. Maybe it's like driving vehicle, playing game, such things. The program is provided a feedback in terms of rewards and punishments. So typically this reinforcement learning typically happens in gaming industry. So wherein the concept of reinforcement learning is like rewards and punishment. So that is like every time a child makes a mistake, mother belts him. I mean, he gets a proper beating. The same way, if a child does something good, you appreciate him and you give him a chocolate. The same logic is applied here. A machine does something good, you give a reward. Reward is like adding weightage. For a machine, a reward would be adding weightage to certain things. Whereas a punishment would be a negative of that. So this reinforcement learning is widely used in terms of gaming industry and autonomous driving. Google, they have smart cars where there is driverless cars. So those industries, those spaces, this reinforcement learning is widely used. But typically for our software field, I mean, for our companies in Bangalore, or maybe most of the companies, they don't use reinforcement learning. It's a still to be explored area. It's not like completely explored. It's still to be explored, reinforcement learning. And what is semi-supervised learning? Semi-supervised learning is wherein when we have a data of maybe 1 lakh records, out of that 1 lakh records, we might know that 50,000 of these records belong to so-and-so label. What I mean by label here is 50,000 records, we know that the output is this. This is what the output is, and this is what the pattern is. But for the rest of the 50,000, we don't know what the output is typically. It's clueless. So these kind of scenarios are semi-supervised learning. So semi-supervised learning and supervised learning is almost the same, just that this variable y, the output y, we don't have the output y for the entire set of x, entire set of inputs. We just have 50% of it, or maybe certain percentage. That's where semi-supervised learning comes into picture. Typical example that I've given here is photo archive, wherein the images are labeled. Same stuff like when you use Google Lens, it might not identify all the objects. Maybe tomorrow you scan your some sort of new chair or some sort of a football that typically it's something new. Let's assume Google had not trained that image with. In that case, the Google Lens will not identify that image. It would say that not sure or something. It will not, or maybe it will map it to a wrong label, something like that. So typically supervised learning is that area wherein there are a lot of techniques wherein we can enhance that stuff, wherein even if it's not labeled, we have techniques wherein we can label up those things and identify the stuff. Unsupervised learning. So unsupervised learning is completely wherein you don't have X, you don't have Y, you just have some sort of data. You will have to do analysis. You will have to see what this data looks like. Does it have some sort of patterns, or does it have some sort of correlations or relations? Then you come up with a hypothesis saying that this data is something like this. A typical example I would say is that stock market. So in stock market, I'm not sure whether you guys are completely aware of stock market, but you might have seen the fancy BSE, NSE coming up in papers, newspapers, or any place, Sensex, those kind of things. So typically what happens is like in stock market is like there's a lot of patterns, or I would say charts. In charts and patterns, you see a lot of data points wherein nobody has explored it. People have their own hypothesis. People have their own algorithms to see certain patterns. But still, there are a lot of spaces wherein you can crack identify your own new patterns or new stuff. So that's some area which I would say like it's kind of unsupervised machine learning where it can be applied. Similarly, there are a lot of other parts also, maybe like healthcare itself. Healthcare, currently doctors, typically medical doctors, they know only the diseases that they have learned in their textbooks. They would have done MBBS for 5 years and plus 3 years of specialization. Whatever they have learned in their textbooks, that's the only thing they know. Suppose let's assume there is a new virus or a new COVID thing, or maybe some sort of new thing comes. Typically, doctors are clueless. They'll have to give it further for R&D, identify what is this new stuff, and then only they can come up with a vaccine or any sort of treatment for that. So that area or that segment is categorized as unsupervised learning, wherein machines would typically see the data and observe for new patterns, and they would say that, okay, this is a new pathway that can be established. So that area or that segment is called as unsupervised machine learning. So we have come up to this point. So guys, before I take you further, do you guys have any doubts or any questions related to these stuff, whatever I spoke?
No, sir.
Okay. So let's take a simple use case, how a ML algorithm, or what's a development process for a ML algorithm or a machine. So what shall we take? Let's take in CIT. Let's take CIT final year's example itself. Like maybe what shall we try to predict is, one sec. Let's try to predict who will be the topper for the upcoming final semester. Okay, so maybe or the first year or the final year, any sort of years. Typically with the data of all the internals, or maybe let's take final year, final semester, or maybe the entire topper predictions, something like that. So what would we do? We need the typical data of that student from semester 1 till semester 7. We will see that, okay, in all the internals, in all the subjects, how has he performed? We need to take all this data, feed it to the model. So before we feed the data to the model, there are certain set of things that we have to do. So what are those certain set of things? That is, first is data analysis. So what does data analysis means? You see, maybe in final year, how many? Maybe 60 students might be there in final year now. So you take these 60 students, entire data from semester 1 till semester 7, and you see that which student is performing in some analysis that you do. Then see that, okay, what are the outliers? So what do we mean by outliers? Outliers are like, maybe when you get this data from your HOD missed certain data points. Maybe he or she entered certain wrong data points. So giving a wrong data point would add a negative signal to the model. So typically we call those wrong data as outliers. So before the data is fed to the model, we'll have to remove all these sort of outliers. So these kind of things will be done in data analysis and feature engineering. So feature engineering is a process or activity which will clean up the data. Now, typically it's pure statistics that we do here. So we will take all the data from 1 to 7 semesters. We will see whether the data is balanced, whether it's unbalanced, or what are the outliers, whether we have some null characters, or whether it has empty things, empty values. Those kind of things we'll see. And typically then next process we would go to is variable selection. So what is variable selection? Let's see in terms of same model building for prediction of a topper for final year. What are the different features that we can consider? Features would be like, what I can think of now is like maybe like different scores on internals, externals from 1 to 7. That is one feature set. Next would be whether this student participates in sports, what is it, what are in sports curriculum, maybe what is his daily routine, does he wake up by 5 o'clock, does he sleep by 10. These are different set of features. You might be thinking, what does it what will these features do in order to predict that whether a student is topper or not? But typically we will consider all sort of activities of a student on a day-to-day basis in order to predict whether this guy will become a topper or not. Same thing we'll do in all the scenarios, medical or maybe business or any sort of things. We'll consider different feature sets, and we typically call all these as feature sets. And what is how frequent he can, I mean, maybe his what do you say, leisure time, how many hours he studies, how many hours he spends in front of gaming, or maybe in terms of some chit chatting, gossiping, these kind of things. All these sort of data of a overall data of a student, we do this for 60 students. We take all the data for 60 students. Maybe there are 20 feature sets, 20 different feature sets, including the internal marks, external marks, student sleep pattern and food intake, leisure, how many hours he studies, how many hours he plays or whatever. These kind of feature sets we take. Then we do feature engineering on top of it. So when we do feature engineering, we'll see maybe typically as part of feature engineering, out of 60 students, we might get only 50 students with good data. Rest of the 10 students, the data is kind of bad, in the sense the students have not given a good data. They have given some junk data. So in that case, we'll have to ignore those kind of data. So that process of ignoring data, cleaning up of data comes under feature engineering and variable selection and data analysis. So this is a typical thing that we do before the data is fed to the model. And once the data is cleaned up completely, then we feed it to the model. That is this part, machine learning model building. Feed it to the model, and the model will see the different patterns in the data. Maybe the guy who studies more, his number of hours are more, study hours are more, and typically his internal scores might be more. And maybe he's part of sports also, and typically different feature sets. We'll see all these, and we see in the previous history how has he performed. Based on all this, we can predict that in the final year, what would be his internal score, or what would be his aggregate. This is a typical process or a pipeline of a ML. I hope this scenario gave you a better understanding of what exactly a ML is. Guys, please talk.
Yes, sir.
Okay. So any questions here? Like, are you guys curious? Like, why would we consider his sleep hours, or maybe why would he consider his study hours or something like that? Okay. Okay. One more thing I would say is, like, there are different. If you see here, so unsupervised learning or supervised learning, we have image classification, customer retention, diagnostics. There are different areas or different segments. But under supervised machine learning, where is supervised machine learning? Yeah. Under supervised machine learning, we have two main things. One is regression and classification. So what is regression? The typical example that I gave you now, predicting students' score in final year. That is, like, we know that in past 7 semesters, he performed so and so. And what would be his score in 8th semester? That is a typical regression problem, wherein you know that till 7th semester, maybe one guy, student A, he had like 78. And in 8th semester, what would he be? Would he be above 78, or would he be below 78, or what is a typical aggregate or a score might be? So this typical example, what I gave you, is a regression problem. The system attempts to predict a value for an input based on the past data. It's typically you one sec, sorry. Yeah. So I hope you guys understood that this scenario is just that we know the past data, that's like 1 to 7 semester. We know that these are the scores, and we just have to predict one extra new score, or maybe 1 or 2 extra new scores. That's a regression problem. What's a typical classification problem? So classification problem would be, let's say, okay, we have images of cats and dogs. So the machine has to classify which is cat and which is dog. Here we don't have to predict any new value, but we just have to classify which is dog and which is cat. So how do we do that? As part of our data, we have thousands or millions of cat images and dog images. We feed it to the model. We know the typical feature sets of how a cat looks and how a dog looks. The machine knows it very well. So once that data is fed to the machine establishes proper pathways, patterns. Once that is done, a new image that you give, maybe you click a new photo of a dog, the machine will automatically tell you whether it's a dog or a cat. So this is a typical classification problem. So in the entire machine ML world, so regression and classification is a main thing that comes into picture. It's either regression or it's either classification. So typically I'll tell you this decision tree is one of the algorithm of ML model. So I'm not going in depth with algorithms. So the reason I've put this image is to make you guys understand on how internally this ML, without doing any sort of programming or without writing any sort of conditions, how would it typically identify or establish pathways? So this particular thing that I have, the diagram that I've put, this is a decision tree formulated for identifying a risk of kidney stones. So before a doctor can say that he has kidney stones, a patient's kidney stone can be identified by a machine learning model. So how is it done? So typically these blocks, these oval things that you see, these are the feature sets. These are all feature sets. Obese since childhood, yes or no. Typically, if we didn't have a machine learning model, this is how we had to do. We had to write if conditions, cases, wherein we say that obese childhood is obese since childhood, yes or no. Then typically family history of hypertension. First, second, these are different grades, maybe low, moderate, or no. So this is a second set of feature set. Next, coffee consumption. If there is coffee consumption, we have to further drill down. If there is no coffee consumption, then eat late at night, yes or no. So these are the typical questions a doctor asks when a patient goes to the clinic. So these typical questions a doctor would have asked, but you would have never considered, or you would have never thought through why this doctor asked so and so. So as part of ML, when we build models, these are the certain set of questions or data points or feature sets that we need in order to predict whether a patient can develop kidney stones or will have kidney stones in certain time. So this is how a typically a ML model internally works. So we don't have to write these if conditions. Rather, the model will establish these pathways using different algorithms that it has. So decision tree is one of the algorithm that we use most widely. So ML is fine. So what is neural network? See, guys, I'm not going in depth with anything, because if I go in depth, it will go above the head. So I'm just giving you a glimpse of certain things. So there's one more area called as neural network. So how is it different from these kind of algorithms, ML models? So neural networks are exact replica of human brain. So typically we have a neuron. So in human brain, every time you learn something new, the neuron pattern in the brain changes. It varies. It creates a new pattern altogether. It's the same thing we do it in neural networks also. So neural network class of machine learning algorithm used to model complex blah blah whatever linear patterns. So let's see what a neuron is exactly. So a neuron, it takes some inputs and fires an output. So if it has to take an input and fire an output, there should be something internally which is doing that, right? So that internally which does is a pure mathematical function, which we call as activation functions. So there are 3 or 4 widely used activations functions like sigmoid, um, tangent. There are few activation functions which will be sitting on each of these neurons. You see the diagram, right? So in the diagram, blue, 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 there's an entire layer of blue, entire layer of yellow, entire layer of green. So each of these round bubble is a neuron, and inside a neuron there is only a typical activation function or a mathematical formula which will transform a certain data in a certain way. And this entire chain of bubbles, right? This forms an entire layer. So when there are like 5 neurons in a layer, these 5 neurons would be taking 5 different feature sets. So feature sets are typically these kind of things I just mentioned. And each of these feature sets, it will try to mix and match and see different pathways that can be established. So in a neural network, there are something called as deep. There is a small variation where is a simple neural network and a deep. So deep is same as simple, but just that will increase the number of layers. The more the layers, the more complexity and more computation power and more time and the better performance. So this is the main difference between a neural network and a and a ML models, ML algorithms. Whereas ML algorithms, typically they don't behave this way. They don't have a neuron. They would internally have pathways established something like this. Okay. So everything in ML looks rosy. It's all nice, fancy stuff. But there should be some downside also with ML, right? So what are the downsides of ML? One thing is data acquisition. So unless we have huge data, the models won't be performing really good. So acquiring of huge data is something challenging. Companies like Facebook and Google, they easily have it. But for a layman like us, or maybe a small company, to get a huge data is a challenge. It's quite a huge challenge. And time and resource. So even for processing huge data, we need a huge resource. A small 8 GB MacBook or a i5 core processor would not be sufficient when you have to process a huge huge load of data. So you will have to have GPUs, which are kind of expensive. So that's one thing. And next thing is explainability. So typically, since ML is like a black box, say, like as I mentioned earlier, everything happens within a model. So even here, everything happens within a model. So you don't see a logic or a if condition or a cases written outside. So typically, you will not know what is happening inside. So that area is called as explainability. So this is one of the area that currently is explored a lot, wherein when a model predicts certain thing, we'll have to explain why it predicted this rather than something else. So we'll have to give a proper explanation why a model has predicted certain thing and why not other things. So that area is called explainability, and that is still still an area which can be explored a lot. There's a lot of opportunity to explore more because it's still a niche area wherein not many people have done something amazing in this area. High errors, sustainability, and bias predictions, overfitting, underfitting. So what does this mean? So if at all, if a data that we feed to the model is slightly wrong, that is as part of feature engineering, where is feature engineering or variable selection, we did something wrong. We have not done the right thing here. we have not removed outliers, or maybe we have not cleaned up the data well. In that case, it's highly possible that the predictions that we get is kind of biased or overfitting, underfitting. So overfitting, underfitting is like either it's like it says that all whatever you in terms of cat and dog, maybe you have too much of cat images and you have less dog images. So even if the if even if a dog image is given to the model and it's a side image or maybe a back image, the model will start predicting it as cat. So those kind of scenarios are can happen. The reason is the data has to be cleaned and we need a lot of data. That's the main reason of this downside. Yeah. Next, let's see applications of ML and AI. So yeah, Facebook is using ML to tag friends in your uploaded picture, and also recommendations based on interest history. So this is something I mentioned earlier also. So normally Facebook gives you a lot of recommendations. So how does it happen? Suppose a new person joins Facebook and he might be your friend, and typically you'll get a recommendation that this guy add him as a friend. So all this typically when it has to happen, uh, I don't know whether you guys were curious to figure out or think through why is it showing up for me? How is this recommendation showing up for me? Though how does Facebook know that this guy is a friend of mine? So all this is happening just because of a huge amount of data that Facebook has in their side, wherein they have a lot of models built on top of this data. Because of that, they do all this tagging, recommendations, and stuff like that. And also in terms of Gmail, also we have this particular email has to go to the spam box. We have three categories: priority, social, promotion, and spam box. Even that email categorization by Gmail is done by a ML model. When that's typically done by a ML model. Healthcare is like a amazing part. Like even I've been working in healthcare for like past 4 years. So one area that I've worked is diabetes medication prediction. And currently the company where I work is like we do predictions on whether it's for an American market, wherein we predict whether a patient gets transferred to a hospital on certain so and so. So healthcare domain is something a lot of ML expertise is going on, wherein people are trying to replace doctors as much as possible in the areas like especially CT scans, MRIs. Before the doctor sees the report itself, the ML models typically seeing the MRI reports or maybe X-ray reports, it identifies what the issue is. So these areas, these kind of things are done a lot. Healthcare is like totally taken over by ML models, I would say. And business, even in business, logistics, transportation networks, building customer profiles. Typically, this is for marketing. People build customer profiles like how Facebook does, increasing in order to increase the sales and marketing. So typically, example to be given is like you might like certain brand of t-shirts or certain brand of shoes. So Google or Facebook, they would have captured all your interests, wherein every time you browse certain things, they'll capture that. And every time as part of advertisement, they will give you, in order to increase the sales from whatever advertisement company it is, they'll typically push the those kind of advertisements to you based on your customer profile. So they would have built a profile of each individual, and based on your choice or your likes, they will push the advertisements to you. So typically that's also ML application again. Education, yeah, this is something people have recently started doing, wherein early identification of students who struggle in curriculum. So who students who are slightly struggling in terms of curriculum education or studying certain languages or certain subjects, we the models will identify those students early and help these lecturers or teachers know that special care or special attention needs to be taken care of so and so students. So this is also something in an education that's been done. Okay, so I've I've spoken about most of the things on an overview. I've not gone in depth of all these things, but I would definitely say that, guys, this is my GitHub link, like K7 in GitHub. You have to, first thing is like, you guys have to create a profile in GitHub, start creating some projects, or maybe you go through some existing projects. You find a lot of open source projects in GitHub, wherein you just have to come look into certain GitHub projects and start. It's like putting some baby steps on these segments. And also there is places wherein in projects they would have mentioned what are the issues in the projects. So when people would have mentioned the issues, like typically, let me show you, like if you open up a GitHub project, you will see that there is an issue section. So if you go to the issue section, let's take issues. So if you go to this issue section, you will see a lot of issues listed down. So once issue is listed down, you guys as new developers, you can just try to fix it and raise a pull request to the respective repository. That would help you in contributing to the open source and also help you in understanding how a typical project works. Coming back, so if you guys are really interested in ML, exploring ML, understanding stuff, so there are a few links that I've given here. Kaggle, Colab, Bender. So these platforms help you in learning up stuff, wherein Kaggle, one sec. Yeah, Kaggle is meant only for data scientists or exploring data, wherein they provide you free GPU and free RAMs to do certain set of huge processing. Like normally, as I mentioned, ML requires a lot of computational power. So typically your laptops won't be sufficient for that. So you will need platforms or places where you can do that. So Kaggle does that. Colab is Google's platform, where even they provide GPUs. You can just come register yourself here. And also the advantage of Kaggle is like there are a lot of data scientists and people who explore certain problems. You can see their problems, how they have solved. You can understand it. You can just initially, at least to start off, you can just blindly copy it. In fact, for final years, rather than you guys go to certain institutes to get the projects done, rather than doing all those things, you can come to this platform Kaggle. Come to Kaggle, you will find a lot of open source projects here. Try to understand it, go through it. You can compete in competitions. You can, if you win certain competitions, you'll get lakhs together here. See the prize amount here. So typically, if you want to see how codes are written, let's take up a problem. Let's see visualization data analysis. These are certain things people have written. One sec, let's go through it. Yeah, so they have given in detail like how a visualization can be done, what are the codes, what has to be done. All these you guys have it ready here. You don't have to do anything much. You just have to start understanding the concepts, go through this stuff, try to solve problems here. Just copy or follow certain people in Kaggle who are like really good data scientists. Follow them, try to understand their code, try to solve some new problem. That's how you can learn. So we have Kaggle, we have Colab, Bender, and yeah, this repository is something very useful. This is a friend of mine, Amit. So he has written all sort of deep learning. One sec, let's take certain deep learning. Okay. All sort of techniques, all sort of options that has to be explored in data segment. So he has a very wide range of, it's not a tutorial as such, but he gives you codes as well as explanation of certain things, how it has to be done, why it has to be done, techniques, all these things he gives. This is a very useful repository. or a profile, I would say. If you have to start with data science or ML models, just explore this repository, also Kaggle. Try to solve problems in Kaggle. Go through Kaggle problems. If you're not understanding certain things, you can check with people here. You can interact with people also here. Check with them. Yeah, that's how you can learn stuff. So I guess like I am done with a certain set of explanation. I'm open for questions. Any sort of questions that you guys have, let me know. I'll help you understand, or I'll answer you those questions. Guys.
Yes, students, the session is open for interaction. Please ask questions.
At least some question that you're curious on, how certain things work or something. Not necessary that you have to ask ML questions itself. If you have any sort of software questions, software related questions also, you can ask me.
Thank you, Ayappa. So for your very informative session, and of course we understand that it's a very vast subject, machine learning, AI, deep learning. So, but still, you made it simple with the real-time examples, and so they are studying very basic of ML, and also they have a lab in their curriculum. So,
Okay.
but I do understand that there's a lot of gap between academia and industry.
Exactly.
And so, as you told, so the future is ML. So, can you please suggest any of the internship? So, wherein our final years or our students, they can find a entry to this field with very earlier stage.
Okay, so typically, see, since I have also studied in CIT, so one strong opinion that I have is like, you study anywhere, it doesn't matter. It's individual choice, individual. It's a eager to learn. That's something that has to drive me. So, typically in colleges in Bangalore, these guys they join these startups in final year. When they come to the final year itself, they'll join these startups where they'll be doing internships. So this is one typical way most of the students in Bangalore they do it. But again, the point there is like these are the students who are driven by their passion and interest. So it's all in the hands of students. It's the passion that can drive them. So typically in Bangalore, there are like companies like HackerEarth, HackerRank. Uh, these are the platforms. These companies they provide a platform where you can solve problems, where you can apply for internships easily. They themselves provide internships. So that's one way of going forward, wherein you can apply for internship and work for a company remotely. The other part to that is like, I would say, just coming to this Kaggle platform, solving certain problems. Like for example, if you see here, there are a lot of competitions and questions put up. Let's take up some sort of question like rock, paper, scissors. What is this? Let's see. So you just come here and try to solve a problem. Initially, you might not understand what, like they've given a particular problem, rock, paper, scissors, sometimes called Rochambeau has been a staple. You might be familiar with rock, paper, scissors, guys. I guess everyone knows rock, paper, scissors. So typically here, they're trying to solve the same stuff in ML, I believe. Yeah. I guess let's take a simpler, some real-time better example rather than rock, paper, scissors. It's like hacking the kidney, hash code archive, volcanic eruption prediction. Yeah, let's take volcanic eruption prediction. So these problems, what the people have put here, are actually real-time problems that is happening in the world. And typically there are a lot of participants across the globe who will come and try to solve these problems. So you get the data here itself. You will have the data here. Whatever data that you require, it is here. You have the training set. You have the entire data set here. You can just download. And let's assume as a beginner, you're not aware like how to start. You don't have to do anything. Come to this notebook section, open up some notebook which a guy has done. Try to go through his code. He has already solved it. Try to go through his code and see what exactly he's doing. Let's see. Yeah, let's see what exactly he's doing. He reads the entire training set. These are all cleaning that he is doing. I told you data analysis and feature engineering. So next he would be doing that part. Listener, showing the number of segments. These are fine. Yeah. So sort values. These are typically cleanup process that he does. Then he tries to visualize the entire data. Once he visualizes what can be done, this is an area wherein, or this is a path people, I mean students have to take, wherein they have to see real-time problems, try to solve it. If they don't, if in order to start off, they can just follow certain notebooks or certain people here. Once they get an understanding, they can solve it. Here itself, if the more they solve, the more better they become, especially in ML. And also here, since it's a competition, if your code is really good, you will win a lot of money also. And once you have a good profile in Kaggle and Git, these are the two things. Normally, any sort of companies, any startups you go, these are the two things they generally check. One is your GitHub profile. One is if you're getting into ML, Kaggle profile. If you have a good Kaggle profile with a lot of problems solved and a lot of projects done in Git, people, I would say typically they don't bother what your aggregate is, or they won't bother what your interview process, what kind of, they'll never ask you any sort of entry level questions. They'll blindly ask, maybe they might ask you a few technical questions and they'll let you in. That's like a huge weightage if you have a strong GitHub profile and a Kaggle profile. Even for internships, companies take interviews, and during the interviews, what they look forward is again Kaggle profile and GitHub profile. If you have a GitHub profile with some projects done, it's like plus 100 boost to your portfolio. So typically most of the students in Bangalore, they have a very strong GitHub profile. In 7th, 6th semester onwards, they start joining companies where they work for them. Yeah, so that's how it has to be. That's how it is. I hope I answered the questions, ma'am.
Yeah. So thank you so much, Appaya. Definitely, I think the students have acquired enough value addition for their career. And dear students, I think in spite of his busy schedule with lot of patience, he has shown the live examples where you can browse and you can build a career. So being at your place, you need not even go to cities. I think definitely students have to utilize this opportunity and you have to explore and get expertise. So thank you, Ayyappa.
Thank you, ma'am. And students, anytime you can reach me out for any help or anything. Should not be a problem. Yeah.
Thank you, sir. It was a highly informative session. We owe a lot for you for enhancing our knowledge horizon. I now appeal to Mr. Muralidhar BM, Assistant Professor, Department of Computer Science and Engineering, to deliver the vote of thanks.
Yes. So gratitude is an honest feeling that springs from the heart. It's my privilege to express gratitude to all those who have contributed for the success of the webinar. I express my heartfelt thanks to the resource person, Mr. Kenneth Ayyappa, for sharing his knowledge insights with us. The session was highly educative. We look forward for your support in our future endeavors. Thank you, sir. A deep sense of gratitude to our principal, Dr. M. Basavaraj, for his encouragement in organizing this webinar. Thank you, sir. Hearty thanks to our HOD, Dr. Kavita PC, for her never-ending enthusiasm and support given to all of us. Thank you, ma'am. Last but not the least, I would like to thank all the staff and students for attending this webinar and making use of it. Thank you, one and all.
Kirtana, before we conclude, can we hear from any of the students, at least reflections?
Yes, ma'am.
Yeah.
Yes, Grishma, can you please give your feedback about the session?
It's a very effective session, and we could get to know more about ML, since we have only the basics in the academics, and it was very useful. Like as our HOD said, the academics and the industry level basis is way different. And yeah, the websites the sir has recommended, the Kaggle and the GitHub, it is also useful. So I think we should make the best use of it and solve problems in those.
Yeah, thank you, Grishma. So meanwhile, I advise all the students to make best use of it and reach to Kenny Tapaya so that this webinar will be worthy. That's what we expect. And we also expect you to come back after a few days after browsing these resources. Yeah,
Yes.
thank you.
Yes, thank you, ma'am. And thank you, sir.
Thank you, sir. We look forward for more sessions from you.
Okay.
Thank you very much.
Thank you, one and all. Yeah.